Hey everyone, Sukanya here. Today we're going to be solving this integral, integration cos to the power of 5x over sine x dx. And I'm going to show you the incorrect way to do it first because I think it's the most common way when we see integrals such as cos and sine. Essentially what I did, I broke apart cos to the power of 5x into cos x and cos to the power of 4x, and then I rewrote this as cot x, and I got this. But as you can see from here, there's no clear relationship between trigonometric functions cot and cos x. We don't have a clear relationship between those two, and we also can't apply u substitution for that same reason. So let's actually pedal backwards and now see what we can do to get the correct answer. So instead of rewriting this integral in terms of cot like we just saw, I'm going to rewrite the integral in terms of this. And the reason I wrote it in terms of this is because, as said before, I know that cos to the power of 5x is the same thing as cos x, and then cos to the power of 4x. I know that cos to the power of 4x is just cos squared x, and then squared that. And I also know that cos squared x is just 1 minus sine squared x. So essentially, I'm converting everything to sine. And we, of course, have that one cos, which is this part right over here. But now you could see that there's an easier relationship between sine and cos. And using that relationship, we can apply u substitution. So I'm going to let u equal to sine x, and therefore du is equal to cos x dx. And we see that we have a cos x dx up over here. Let's replace that with du. So I replace sine x with u, and then cos x dx with du. I'm just going to simplify this. I expanded the top, and now I'm going to simplify it even more. And finally, these are pretty easy terms to take integrals of, so I'm just going to go ahead and do that. Of course, we can't leave our answer in terms of u, so I'm going to rewrite this in terms of x. And this is our final answer.